Okay, number 27. The world's population has grown at an average rate of 1.9% per year since 1945. There were approximately 4 billion people in the world in 1975. Which the following function represent the world's population P in billions of people T years since 1975. Okay, so we know the population grow by 1.9% each year. And approximately there are 4 billion people in 1975. So this is actually an exponential model. Okay, because each year we're not adding the same amount, is 1.9% of the total. So as the population gets bigger and bigger, 1.9% of the total population also gets bigger and bigger, right? So it's not a constant amount that we're adding each year. So this is not a linear model, should be exponential model. Okay, so once we decided it's an exponential model, then we can pretty much eliminate C and D because C and D is y equal to mx plus b. That's the linear equation form. Okay, so it's exponential model, so the t should be in the exponent. Okay, t should be in the exponent. So what we can do here now is the say the exponential model, we get y equal to, okay, it'll be it's always the number that we begin with. Okay, we can say this is a time in parentheses, that's the rate, it's a growth rate, and then that raised to the exponent, which in this case will be the amount of time, so that will be t. Okay, so the a bar is always the initial amount, so that's what we begin with, which is 4. Okay, 4 billion people right there, and then times r. Well, what's r? So it increases at 1.9% each year. Okay, so to figure out the growth rate, we have to take the percentage and then convert to a decimal, and then we, since a percent increase, we always add it to 1. Okay, we had to add this to 1. So it'll be 1 plus 1.9% is 0.019. Okay, so we get 1.019, and this will be the growth rate. Okay, the growth rate or the growth factor here. The growth factor 1.019, that's what goes in the parentheses. Okay, so as the increase, we always add it to 1. The decrease, we subtract from 1. Okay, so 1 represents like 100%, so that's the original amount. Okay, yep, and then once we have that, we can say t is exponent. So for our, however many years we have, we just put that as the exponent. Okay, and that should be the equation. So in this model, it represents population in billions, so it's already in billions, so we don't have to worry about converting because the 4 is also in billions, so everything matches. So that should be our answer. Okay, so as a function notation will be p of t equal to 4 times 1.019 raised to t. So should be letter A for question 27.